In just 6 days, VCF SouthWest is going to be in full swing, and I intend to have both of these machines there on display. Here we have a Data General Nova 1210 with an ADM3A data terminal sitting on top of it and a Tektran tape drive acting as mass storage. It's a very compact but pretty typical mini computer from the early 1970s. Over here, though, we have a PDP-1173 with 2 megabytes of memory, full graphical capabilities, as well as a huge vector processor bolted to the side of it. This thing is very nearly a supercomputer from the late 1980s. Two wildly different machines, but there is a thread that connects the both of them. And that is that in a previous life, they were each hooked up to a spectrometer of some kind. So a pretty interesting collection here, and I think it'll be a ton of fun to see people getting hands-on with these at the show. But I realize that not everybody watching is going to be able to make it to the show, so today, y'all are going to get a private tour of both of these. This is the Data General Nova 1210, and right above it is the ADM3A data terminal that I'm going to run with it, and over here is the Tektran data cassette. So first things first, let's make sure that the bootstrap loader here is in memory. That's at 057757. We will examine that. Looks like the value is 126440. That looks correct. So let's just go ahead and start running this. Now, there's no data for the first bit of the tape here, so I gotta hit the read button until it actually gets to data. Okay, now it's reading in. This should be reading in the binary loader into memory. All right, it looks like the read finished. So let's go to stop, and we want to examine 157777. Let's examine that. There should be 000663 in there. That looks correct. So let's just go ahead and start executing from this location. It is running. It's gonna take me hitting the button a few times to get it to some actual, hey, all right. Now this is going to take about a minute, so let's talk a bit about the Nova itself. The 1210 is essentially a desktop-sized 1200. There's only 4 slots in the backplane. That opened up some space on the backplane for them to integrate the power supply into the backplane and shorten the entire length of the machine up. But the CPU is a full-fledged Nova 1200 CPU. Notably, it uses a 74S181. This is a 4-bit ALU. So while this is a 16-bit machine, it has processor time groups that it pulls through and runs 4 nibbles at a time through this poor little 4-bit ALU. For memory, we have an 8K core memory plane in it, as well as a 16K core memory plane in it, for a total of 24K of core memory. And look at that. Commas, 14 spaces, type Y or N. We just loaded up a program from this data tape into core memory, and it's now executing it. So if I type Y here, I'm just at a prompt. This prompt is basic. Now, before we start typing a program in, let's talk about how that basic software got from a plain Jane audio cassette in here over into core memory. And that happened via this Tektran Industries 8410 data cassette. It uses 2 tracks that span the entire width of the tape. One is data and one is a clock. And it's laying down information and reading it back as raw magnetic flux transitions. This allows them to make the data far more dense than ever would be possible if you were laying it down as actual audio data. So this thing is essentially a 2-track desktop-sized version of the old 9-track data tapes that were used on like mainframes and heavy machinery. But you noticed that when I was trying to read in data, I had to hit the read button a bunch of times. And that's because I've laid down the data with large swaths of nothing in the middle. And the way that this Tektran works is that if it doesn't pick up a clock, it just cancels the read. Now, this is not the correct way to use this 8410 because you can actually write down headers and footers and then allow you to randomly search for blocks of data by just sending it control codes. So for the time being, we're just going to use it the way the original users intended, and we're just going to keep hitting the read button until it picks up the data and lays it down into core memory. And once it's into core memory, it starts executing and we get burp. Now, burp stands for Basic Language User Responsive Program. Edix apparently had a sense of humor, and this is not the only hilariously named program that they have. They also have Belch, which stands for Basic EDAX Language for Computer Handling. I unfortunately don't have a copy of Belch, but we do have a copy of Burp. This is effectively Dartmouth Basic, but it has a couple of extra things added in. The first is what they call a desk calculator mode. You can actually just punch in straight equations here, like 2 plus 3. Nope. All right, when in doubt, read the manual. I apparently forgot how to use the desktop calculator. Okay, so I have to do like a print 2 plus 3, and that should equal 5. There we go, all right. It's not the most intuitive thing, but you can also do more complex things like adding in parentheses and do like a 3 times 5 minus 6, and that gives us 9. So desktop calculator is pretty interesting. You can do other things like say let A equal 23, let B equal 4, print A times B, and we get 92. Now, everything else is pretty much standard Dartmouth Basic, except for 3 extra little commands right here at the end. Get 0, get 1, and get 2. This initializes the 707 interface for reading, reads one channel value, or closes the 707 interface. Now, I've never actually tried to run these, so let's do get 0, error 9. I have absolutely no idea how to use these. I think even if I could figure out how to use those, until I figure out what the pinout of the giant plug that I got with this thing that plugs straight into the backplane is, we can't really do a whole lot with these. Now, Burp is awesome because it's called Burp, but also I don't think anybody did really serious work with this program. However, we did recover one more piece of software with the original data tape that we got with this machine called 7EP. And I do have the manual for 7EP here, but here's the problem. 7EP is an 8K program for use with a 707 series analyzer. It is intended for use with energy dispersive X-ray spectra generated by electron bombardment and contains specific quantitative programs appropriate to the analysis of bulk specimens such as are normally encountered in the SEM or microprobe. So I don't have enough schooling to know what like 60% of the words in that sentence are, but we did actually try to run 7EP and we got almost nowhere with it, which makes sense. This is a program that is specifically meant for use with a 707 series analyzer. But in the meantime, I love playing around with Burp, and this Data General Nova is just such a gorgeous machine, and I'm really excited to get it up to VCF SouthWest and let people get hands-on with it. This is a PDP-1173, but you'd be forgiven for not recognizing that immediately because it looks like no other PDP-11 on the planet. Now, the entire story of how this thing got to be in this shape sitting on this table is a little wild, but it starts about 3 years ago when a gentleman by the name of Mike gave me a ring and said, "Hey, I've got a bunch of PDP-11 kit. Would you be interested in it?" And I said, absolutely. I made a beeline straight for Austin, and I had an absolute blast hanging out with Mike. So Mike, if you're watching, thank you so much for that. I still talk about my trip to your lab. It was stunning and just a massive amount of fun. But it turns out that Mike used to work for a company called Bowman. And Bowman builds infrared and laser spectrometers, doing some really wild work. But all of the constituent parts for this machine came out of a Bowman computer, which actually was an entire desk. It looks like this. You can see there's like this box with an 8-inch floppy and all of the cards on the inside that slides into a desk. This card cage is actually from a different machine. It's an 1103 18-bit card cage that I hot-wired for 22-bit addressing, and it seems to work just fine with all of the components that we have in here. Right up front here, we've got the PDP-11 CPU. You can see it's got this gorgeous white ceramic DCJ11 CPU right on the front of it. Now, right below that is a QRAM 22B memory card. It was originally spec'd out with 1 megabyte, but I have maxed that out to a full 2 megabytes. But with 22-bit addressing, we could go all the way up to 4 megabytes. I just don't have another one of these QRAM cards here. If we skip these two here and go down to this one, this is a Sigma 8-inch floppy controller that connects up to this half-height 8-inch drive over here. It emulates an RX-02, but writes a normal disk, unlike the insanity of the RX-02. Right below that, we have a Wombat MFM controller, which plugs into this run-of-the-mill Seagate ST4097 MFM drive here on the bottom. But there are 3 full-height cards here that are very interesting. These two here are connected via a short 50-pin ribbon cable right here in the center. One is the BOMIM DEB41. This is a custom card built by BOMIM themselves, and it's connected up to a Matrox QRGB card. Now, the Matrox QRGB card generates a video signal that is used with a standard RGB color monitor. But by plugging it into BOMIM's custom DEB41 here, we get a couple of extra interesting features. This DEB41 emulates a serial card, but what this means is that they can intermix ASCII serial text and full color graphics on the same screen. So that's why we can use the Princeton RGB monitor and BOMIM's custom keyboard, and we don't have to plug in a data terminal with a separate monitor. It all shows up on the same screen. Now, this third and final card here has 2 massive 60-pin, I believe, cables coming out of it. And this is a BOMIM DEB18. This is an HPVP DMA interface card. HPVP stands for High Performance Vector Processor. This vector processor is not only the most special piece of equipment on this entire contraption, it's one of the most special pieces of equipment in this entire room. This thing effectively turns this box into a Supermini. It's a mini computer with supercomputer performance. And it does that with an AM29116 processor right here in the middle. This is a 16-bit bit slice processor. Then we also have 2 Waytech WTL1066s here and a legion of other logic that connects it all with ROMs and static RAMs that are unbelievably fast. And I'm not even gonna pretend I know what's going on in here. I know that it is ridiculously fast and it is dynamically configurable because the microcode that runs all of the processors on here is stored in RAM, and the microcode is dynamically loaded in by the software, which means you can reconfigure your processor on the fly. That is insane. That's all well and good, but that doesn't explain why I've got a supercomputer bolted to a kind of a strange looking wooden case here. This is certainly not how BOMIM would have sent it out. They would have sent it out in a desk, but I didn't get the desk. I did get a ton of documentation though, and looking through this, I was able to figure out that aside from the desk and the spectrometer itself, we had enough components to build a complete system. And I really, really wanted to see this vector processor come up and do supercomputing stuff. But without the desk and the original case that it was supposed to go in, I didn't really know the best way to build this thing out. So I was talking with my buddies over on the Discord, and we decided, hey, let's just build this thing together. So for like the last 4 months, every Friday night at 9:30 p.m. Central Time, we go live and we all join in and we built this thing together. This is a community collaborative effort and the results are absolutely stunning. All of the difficulty in coming up with the design, how to bolt things together, figuring out pinouts for these super rare, weird cards, troubleshooting it once it didn't work the first time we tried bringing everything up, and then getting it all up and going and finally doing real deal supercomputing on this machine. It's all thanks to you guys. It's all thanks to the guys over on the Discord that helped me build this thing together. Every Friday night at 9:30 p.m. Central Time, we go live. This has become like a really special time for me. I look forward to this every week. Having said that, it's not gonna happen this coming Friday because I'm gonna be at VCF SouthWest actually running and displaying this thing. Speaking of which, let's put some electrons in it and see what happens. The monitor has warmed up. I'll reach around to the back and flip the power switch here. And yep, we came up halted. That's because I had the halt switch flipped here on the front panel. I like to boot up with halt flipped, so that way the hard drive has a moment to spin up. We'll come off of halt. I will hit the reset switch here. There we go, SRQ D11 boot version 4.5. This is that Wombat card booting off of the MFM drive right here. There we go, RSX 11M version 4.1, BL35D, 1024K mapped. Now this is interesting. It looks like maybe we only have 1 meg of memory. We actually have a full 2 megs of memory. This is talking about kilo words, and a word is 16 bits. So that is 1,000 kilowords or 2 megabytes. Please enter the date and time. Today is Christmas in 1984. So Merry Christmas, guys. Now we're loading in all of the interesting settings and things that they had set up specifically for this BOMIM system. Entering memory size for co-addition, I have no idea what that means. We just hit return on that and it seems to continue on through. Now it's gonna start loading in all of the custom drivers. We should see the screen flicker here in a second. There it goes. That was the Matrox graphic driver getting reinitialized. So exciting. That means that we have color graphics going on, and there it goes. Bye. We're sitting at a prompt. All I got to do is type hello Usagi. It's going to ask me for a password. The password is Usagi, so if you're at the VCF SouthWest, you can break into my system there. It says good afternoon. Now from here we can do a couple of things, like we can do a directory listing here and see what all is going on in there, but you know what? Let's just go straight into the party piece. Let's type in menu, hit enter, check this out. Full color graphics, BOMIM DA2, DA3 series. Now we have a lot of options that we can do from here, but let's start with just stat for status. Now, keep close eye up here. Wait loading microcode. It is now loading the microcode into the vector processor for this particular thing. So we are dynamically configuring the vector processor for the status screen. How awesome is that? That means that we're using that vector processor. There we go, status spectrophotometer running. There you go, it's working. Let's see if we can do some calculations here. Let's do Control Z. Let's try complex FFT over here for fast Fourier transform. There we go. So our interferogram is referenc.igm. This is a reference interferogram that we found on a floppy disk that we loaded up. Our spectrum is going to be that. Let's just go ahead and hit enter and see what happens. The hard drive is getting hit over here. It's doing all the, there we go. Computing FFT, transferring data from VP to host. We did supercomputing. It just happened so ridiculously fast that we almost didn't see it. It took longer to load the microcode than it did to calculate the FFT. So let's see if we can display that spectrum that we just generated. And instead of .cos, let's change this over to a .spc, that file that we actually generated. Then I'll go ahead and hit return on this. It's hitting the drive, loading data file up here on the top. There it goes. So that kind of weird looking green box right there, that's the reference file. I have a printout from the floppy that we pulled this off of. That's exactly what it's supposed to look like. But this is pretty awesome. We're doing real deal supercomputing. And there you go, two very different machines representing two very different eras of the same field. I would love to someday get my hands on an EDAX 707A for the Nova or a BOMIM DA2 or DA3 for the 1173 over here. Spectroscopy is absolutely fascinating, and I really want to dive into this field more in the future. So I'm going to keep an eye out for a spectrometer that's not going to break the bank. I'm gonna keep my eyes out for a spectrometer that's not gonna break the bank, and maybe someday we'll be able to do some real deal proper science in this room. But if you're gonna be in the area pretty much 1 week from now, I hope to see you at the event. I think it's gonna be a ton of fun, and I'm really looking forward to it. But for everybody else, I wanna thank you all so much for watching, and I hope to see you in the next one.